Let's say, children, a very interesting, a very good sum, right? What's the sum trying to say? It says, in the adjoining figure, PR is 6 unit. Kindly pay attention, it's a really good sum. PR is 6 unit. Let me write down that. PR is 6. PQ is 8. PQ is 8. Angle PRQ given to me, it's 90. Semicircles are drawn. Semicircles are drawn with side PR, RQ and PQ as a diameter. So with RQ as a diameter, a semicircle is drawn. With PR as a diameter, a semicircle is drawn. And with PQ as a diameter, again a semicircle is drawn. What am I supposed to find out? As shown in the figure, find the area of shaded portion. Now children, just look at it. What is the shaded portion? This is what the shaded portion is. This portion and this portion is what we are supposed to find out area of. Now I have given you over here the angle RPQ as 90 degree. Say for an instance, if they don't give you this angle as 90 degree, still you can say it is 90 degree. Why? Angle in a semicircle. Angle in a semicircle. What makes you say that? RQ being the diameter. What is it? It's a semicircle. Angle in a semicircle is right angle. Right, children? Though in my question I have given you it as a data, but if not given, you can always claim this angle as 90 degree. Now, what is this all about? Question arises that by looking at the figure, you might be thinking that it's very easy, but when you practically start working on it, you might feel that, oh, it's not that easy. So understand what am I going to do so. Very first thing, with RPQ being a right angle triangle, can I find out RQ by using Pythagoras? So let me go step by step to make you understand this sum. RPQ, this being 90, 6, 8. Can I work out this? Though everybody might be aware with the answer, 10 is what the answer is. It's a Pythagorean triplet. So let's start our solution. Go step by step and we say what? In triangle PRQ, how much is PR? PR is 6 units. How much is PQ? PQ is 8 units. Measure angle RPQ is 90 degree. Therefore, can I say by Pythagoras theorem? By Pythagoras theorem. What is Pythagoras theorem trying to say, children? RQ square is equals to PR square plus PQ square. So RQ square is equals to PR square 6 square, PQ square 8 square. If you want, you can insert the parenthesis. If you want, you can insert the parenthesis. This is what you can say given to you, equation number 1. This is given. Here also you can say from given. Though we are not doing any hardcore geometry sum, but still. How much is this? RQ square is equals to 36 plus 64. 100 is what RQ square is. Taking square root, RQ turning out to be 10 units. RQ turning out to be 10 units. Any problem, children? Right? Now what? Pay attention what I'm going to make you understand. I'm going to find out first, just keep this in mind what you want to. Just keep this in mind what you want to. And now, what we are going to do is, we are going to find out area of semicircle with PR as a diameter completely. Listen to me carefully. What am I going to do is, I'm going to find out area of semicircle, PR as a diameter. So when you say semicircle, I'm taking a different marker to make you understand. So when you say area of semicircle with PR as a diameter, sir, entire this will come. Yes, I am interested in finding all this. Plus, I shall take area of semicircle with PQ as a diameter. Sir, in that entire this will come. I want that. So what did I do first? Area of semicircle with PR as a diameter. Area of semicircle with PQ as a diameter. Also, I'm going to add to this area of this triangle. Right angle triangle. So exactly what are you up to? Your figure is so messy. I want you people to understand. What did I do so? I found out area of semicircle with PR as a diameter. I found out area of semicircle with PQ as a diameter. I found out area of triangle PRQ, right angle triangle. I add all three. So on adding all three, you are going to get the entire figure. But that's what not your question is. Children, thereafter, after adding 1, 2 and 3, what am I going to do is, I am going to, can you see this semicircle with RQ as a diameter? I am going to subtract area of semicircle with RQ as a diameter. I want you people to see this. See this? I am subtracting. What did I get? I got the thing which I wanted. Did you realize how did we do so? How we went for? We went for area of semicircle with PQ as a diameter, area of semicircle with PQ as a diameter, PR as a diameter, plus the area of triangle. With that, I got an entire figure. But I never wanted that. I wanted only the shaded figure. Thereafter, area of semicircle with RQ as a diameter, subtract that. As simple as that. I hope my children have understood it. Right? So I'm not redrawing the figure. This is what we wanted. So let's write down things over here. So now comes for semicircle with PR as a diameter. For semicircle with PR as diameter. When PR is the diameter, what is diameter PR? PR is equals to, how much is PR, children? 6. So I'll say diameter PR, let me say diameter PR. Diameter PR is 6 units. Its radius, I'm saying it as R1, is 3 units. Radius is half of the diameter. Its area, that means area of semicircle with PR as a diameter. Area A1 is pi R1 square, pi 3 square. Pi R1 is 3, pi 3 square. Let this be as it is. Square units. Any problem? Let's work out. This sum is going to be a bit lengthy, so let's work out over here. Thereafter, we went for area of semicircle with PQ as a diameter. So, on the same lines, children, mind you, on the same lines, for semicircle with who as a diameter? PQ as a diameter. For semicircle with PQ as a diameter. Same children, same lines. What is diameter? Diameter PQ. How much is it? 8 units. So, what is radius? Radius R2. Here we have taken R1. So, we shall take R2. 4 units. All of us are aware. Radius is half of diameter. Its area A2 is again pi, this time R2 square, pi 4 square, square units, R2 square. Any problem? Right? Thereafter we went for area of triangle. What type of triangle it is? It's a right angle triangle. So, for right angled triangle PRQ, area A3 is half into product of perpendicular side. If you want, I can draw once again. This is what I'm drawing via dotted line for you people to understand that what was our figure. This is what it is. So you can understand that this is what it was, and then this is a semicircle. So A3, this is 6, this is 8. So it is half into product of perpendicular side. I'm not writing that formula. So half into PR into PQ. So it is half into 6 into 8. Answer is 24 square centimeter. Let this be as it is. 2 ones are, 3s are. This is how it is, 24. So A3 is 24 square centimeter. I'm sorry, it's units, not given to us as centimeter. Have they? No, it's units. Thereafter, what we went for? Area of RQ. So now for semicircle with RQ as a diameter, with RQ as diameter. What next? Diameter RQ. How much is that? We just now found 10 units. Radius, I'm saying R3, or say, let me say, since I have used the suffix 3 over here, I shall say R4. Though we don't have radius over here, but still I shall say R4. Radius R4 is 5 units. What is its area? Its area is A4. Its area is A4, which is pi R4 square. Pi R4 square, which is pi 5 square units. Now children, what? This is A4. Now children, what? How did I show you? How did I show you that the area of shaded region is? So let's write down the answer here. Let's write down the answer here. Area of shaded region. Area of shaded region. Now people, you can write down area of semicircle with PR as a diameter plus area of semicircle with PQ as a diameter plus area of triangle PRQ minus area of semicircle with RQ as a diameter if you want. But I have given A1, A2, A3, A4 for this reason. So area of shaded region is nothing but A1 plus A2 plus A3, A1 plus A2 plus A3 minus A4. Am I right, children? Am I right? Now what I'm going to do is, as I told you, area of this entire, those who want to see once again, so area of this entire plus area of this entire plus area of this entire, and then what did we went for? We went for subtracting. We went for subtracting. I hope my children are understanding it. I hope my children are understanding, right? This is how we obtained our answer. So what I'm going to do is, since I've seen that A1, A2s and A4s are nothing but related to semicircle, I'm just rearranging it. So I shall say A1 plus A2 minus A4 plus A3. I'm just rearranging it. I can. So what is A1? Pi 3 square. What is A2? Pi 4 square. What is A3? A4 minus pi 5 square. And then A3, 24. Children, pi common from the first 3 terms. Pi common, 3 square, 9, plus 16, minus 25. 3 square, 9, 4 square, 16, 5 square, 25, plus 24. Pi, 25 minus 25, 0, plus 24. Though they have said use pi 3.14, I did not use pi 3.14. Why? Because anything into 0 will give me 0. So 0 plus 24. So what is exactly my answer? 24 square units. What is my exact answer is 24 square units. So what is the area of shaded region? Therefore, area of shaded region is equals to 24 square units. Area of shaded region is 24 square units. Quite interesting, wasn't it? Right? That's the reason I said sum is quite interesting. Dash semicircle, dash semicircle, dash triangle. Sum it up, subtract, that's what.